We are going to discuss basically the principles of electrical engineering in this course. We already had a little bit of question and answer session in the last class. So I had asked you why AC transmission has won over the DC transmission and why not DC. That's what. So we talked about this and we said that the reason is basically the use of transformer that has facilitated the transmission of electricity in the form of AC rather than DC. Then after that, we also talked about why 50 or 60 hertz and why not 5 hertz or 500 hertz. Yeah, so we talked about this as well. And we basically answered this question as in olden days, we were using only incandescent lamps. And at 5 hertz frequency, probably you would see very clearly the fluctuation in the light intensity. Whereas at 50 or 60 hertz, when we have the persistence of vision for almost 1/8 of a second, definitely you would not see this fluctuation. That is the major advantage. But if we talk about 500 hertz, the inductance effect will be felt much more. The losses will be much more. So we didn't want to have extremely large frequency. That is the reason why we have not really chosen large frequency. One more question we talked about in the last class was why 3-phase? Why not single phase? So if we talk about 3-phase, we said that 3-phase mainly allows you to have, like if I look at VA, IA plus VB, IB, please note I'm using lowercase letters, and VC, IC. If I'm talking about VA, IA plus VB, IB plus VC, IC, this is a constant, which means the power delivered by a 3-phase system is a constant. So that is one major advantage we get. So we get torque and power to be constants. So if these two are constants, we are not going to have much of variation in the speed. So the speed variation and vibration, what you see in the shaft, those will be minimized. Okay. Speed variation and vibrations are minimized. So which means less noise. We will have less noise in the motor. And one more advantage, what we talked about in the last class for 3-phase system, that is during the tutorial session, what we talked about was that with 2 conductors in single phase, if you are transmitting P watts of electricity, in 3-phase case, right? Even with just 4 conductors. So you are talking about, in this case, A, B, C, and neutral. You would be able to transmit 3P watts of electricity. That is the major advantage. So which means there is a lot of saving in the amount of copper that we use. Okay, so these are the major 2 advantages that we visualize when we are using 3-phase electricity versus single-phase electricity. Okay, so this is just a recap of what we said in the last class, but we are going to formally start on the course today. So I want to ask you, how do you really see the manifestation of electricity? Anybody? How does electricity manifest itself? Can anybody say how is electricity manifesting itself?
Movement of electrons.
Movement of electrons, you don't visualize, right? Do you see it? I'm asking physically, how do you see it?
When we turn on, I'm lightning.
Lightning? Okay,
Between
so
12.
lightning is one manifestation of electricity. Fine, good. Anything else?
To the form
From
which
the
is
power which is being delivered by in our homes, which
Yeah?
is powering up our appliances.
No, your voice has to be a little louder. Can you tell me?
Ma'am, the electricity which is being supplied to our homes, it's powering our devices and appliances.
So you see it in the form of some light bulb that is actually giving you light, and maybe a mixie, a grinder in your home, which is grinding, certain apparatus, certain food substances, or you see water pumping that is happening in the form of, which is filling your overhead tank. Anything else? So you can also say static electricity, which is charge. You have definitely seen charge, right? So if you look at electricity, how it is manifesting itself, you can say, first of all, in the form of static charge, definitely. You must have seen when you comb your hair on a day when your hair is really dry, then it will be able to attract a piece of paper, small pieces of paper. So that is essentially because of electric charge. I'm sure all of you have noticed this. Okay, that is one way of manifestation of electricity. The second one is current electricity, which you must have seen, which is actually either moving your motor, or it is actually creating a light in your bulb, or any one of those things. So that is current electricity. The third thing is even potential. If you by mistake touch a particular terminal, the electrical terminal, you immediately, jump, because you are going to get a shock. So that is electric potential. So all these things are manifestations of electricity, which we normally see in our day-to-day life, right? But as engineers, as electrical engineers, we are concerned about how we use or applications of electricity. That is what we are worried about. So in this particular course, what we are going to talk about is how really the electricity is applied in a useful manner. That's what we are going to see. Okay. So if you look at an electrical system, the electrical system mainly has two things, or I would say the source and load. We are basically worried about the source and the load. The source is in the form of the generated voltage, and the load is in the form of maybe your light or your motor or any one of those things, whatever where we are going to utilize electricity. So to show it in the form of a block diagram, generally what we are going to have is a source, and it is transmitted ultimately to the load. Okay, so the source could be a battery, it could be a three-phase electricity or single-phase electricity that is coming from the grid, and in between I may have a transmission system. So the transmission system could be as simple as a wire, which you see probably at home. So this may be just a simple transmission system, and this transmission system needs to be ultimately controlled with the help of some kind of control. The control could be as simple as a switch. I can just have a switch. You can turn on a light, you can turn it off. So that is also a control apparatus. So these are the basic portions of an electrical system. So you will have a source, you will have a load, and you will have a transmission system. And the transmission can be controlled with the help of a switch or maybe a resistance. I can reduce the speed of a fan or increase the speed of a fan with the help of resistance. All these things can be done. So this is the basic system that we are going to study in detail. So different kinds of loads we will be studying at different points in time in your coursework. And we will be talking about control eventually when we talk about either power electronics or control system or machines, all those things we'll be talking about. And the transmission system we'll be studying eventually when you do the power systems course, right? So these are the different portions that we will be studying. But in this particular course, we will have an overview of all these systems together, the entire electrical system together. Okay. So if you look at the electrical system, basically we have 4 different subsystems in an electrical system. So we are going to have, one is the generation subsystem itself. The generation is done normally in the form of 3-phase electricity. But lately, because of renewable energy, especially solar, we may generate it in the form of DC. But if you look at the generation of DC, that is at a much lower level. That is, power level is much smaller. So we are going to have larger levels of power generated only in the form of 3-phase electricity. This happens in thermal power station and hydro power station, right? Thermal and hydro power stations. So I hope you guys know the basic working of a power station. Basically, what is done is we will always have either in thermal power station, we will have steam, or in hydro power station, we will have basically water pushed through floodgates.
Ma'am?
And yeah.
What is that besides subsystem, generation subsystem, arrow after that?
3-phase electricity. This is 3-phase.
Okay.
3-phase electricity. Okay, let me write it clearly. 3-phase. So in the generation subsystem, if you are generating power in the form of large amount of quantity, in that case, it will be 3-phase electricity. If it is a smaller quantity, it can be DC through solar. Yes. Somebody said, ma'am.
Yes, ma'am. I was just asking which books to refer to. That has not been informed yet.
Can you please wait, because we are just starting with introduction. I will come to what all modules will be covered in how many hours. Then we will be looking at reference books. Then I'll also give you evaluation policy. Okay. I'll give step by step everything. Okay. Don't worry. So if you look at the generation subsystem, you are going to have basically a steam turbine in the case of a thermal power station, or you will have a water turbine in the case of a hydro power station. This is going to be coupled to a generator, which is generally an AC generator. So this is going to generate power in the form of alternating, power, alternating current and alternating voltage. And this will be essentially transmitted through by using a second subsystem, which is known as transmission subsystem. So the transmission subsystem is going to be having a huge amount of power grid. If you look at our India, basically we have southern power grid, northern power grid. We also have eastern and western power grid. All of them are connected together. So the transmission subsystem essentially consists of the complete power grid. Okay. So after the power grid, it is actually coming in the level of about 765 kV or 400 kV, or even some of them are at 800 kV level. So very high voltage level. At very high voltage level, the power is transmitted through the power grid. And finally, we are going to have, these power grids evacuating the electricity into the distribution system. The distribution system will be visualized in the form of somewhat lower voltage substation. So you may have 33 kV or 11 kV substations available at different distribution centers, from which it will be stepped down further, and ultimately it will become either industrial supply or it will become domestic supply. So finally, when it is coming to either domestic system or industrial system, it will be utilized. So I would call this the last thing as utilization subsystem. So in the yeah.
So the substations are like the transmission of electricity, right? Like from where it's generated to the domestic like houses. Is it like that?
The transmission is basically at a higher level. So what you do is the generated voltage may be only at 11 kV to 15 kV level. Whereas initially, along with the generating stations, there will be small switch yards or bigger switch yard, depending upon the power level, what is being generated at each of the generating stations. And in the switch yard, it will be first of all stepped up so that it comes to transmission level. From the switch yards, long transmission lines will take it to all over the country. So the transmission system is basically high voltage power network, which is going all over the country. We call that as transmission subsystem. So if you actually look at in India, NTPC and NHPC, National Thermal Power Corporation and National Hydropower Corporation, these are responsible for generation, large scale generation. Okay. Nuclear Power Corporation is the third one. Okay, these three organizations are responsible for large scale power generation, whereas transmission is mainly the network is maintained by Power Grid Corporation. Power Grid Corporation is the owner of all the transmission network completely. So they manage everything. They maintain all the power lines basically. And the distribution system is actually maintained by multiple organizations. For example, here you must have heard Telangana State Power Distribution Limited. Okay. So this particular PDCL or whatever corporation limited. So that is the one which is maintaining the distribution of electricity. So you have Tata Power, which is also maintaining distribution of electricity, for example, in Bombay. Similarly, in Delhi also we have multiple distribution companies which are distributing electricity, which means they will maintain the substations which are stepping down the voltage from either 765 or 400 or 800 kV level to 11 kV and 33 kV level. And from there, it is distributed to different houses, different industries at different voltage levels. Do you get this? So the distribution system is the third kind of subsystem, which is going to step down the voltage and keep track of how much energy is consumed by every individual or every industry, and then charging them and recovering the charges. All those things, those are taken care of by the distribution system. And utilization system is the industry itself. So you can say it can be industrial consumers, it can be domestic consumers. Then you have different transportation consumers, for example, railways, that is also a consumer, and metro rail corporations, right? Metro rail systems, those are also consumers. Then you have shopping complexes, offices, malls, and things like that. They are all commercial consumers. So we have different types of consumers. All of them fall under utilization subsystem. Okay. So please make sure that your mics are all muted. Please make sure.
Extremely sorry, ma'am. Extremely sorry.
Yeah. Okay. So this is the utilization subsystem. So these are the four subsystems. But we are not going to really talk so much about each of these subsystems, although I am basically just mentioning their names. But we are going to look at the basic functioning of electricity, how the source and load, they are all connected in the form of circuit, and how exactly you calculate the power, or how you calculate the current, how you calculate the overall resistance or impedance. This is the basic thing that we are going to look at in this particular course. Okay, so we are going to look at it in the form of the components or elements in an electrical network. Okay, that's what we are going to see in this particular course. So we will be primarily looking at RLC, that is resistance, inductance, capacitance, and we'll be looking at voltage sources and current sources.
Ma'am?
Yeah.
So basically, whatever gets generated, the voltage, we increase it for the sake of transmission, and then we keep decreasing until it comes to our homes or something.
Exactly. Exactly.
So
That's
why
what
do we
we do.
increase it for transmission? It travels faster or something.
What is it? Tell me.
Ma'am, we increase the voltage for transmission. Why do we do that? Because it travels faster or something, or
No,
why do we increase?
no. In last class, we talked about this. If you increase the voltage, the current level will come down automatically when you are talking about a fixed amount of power, because the power is the product of voltage and current. You are going to have the power as the product of voltage and current. So if I increase voltage, the current would automatically decrease for a given amount of power. Right? So yes, if the current decreases, I square R losses will automatically come down. We are looking at basically the resistances in the transmission line. The transmission line is made up of copper. The copper will have some minimum amount of resistance. So obviously, if the current is brought down, automatically you are going to bring down the I square R losses in this particular transmission system. That is the first thing. And second thing is, when you increase the voltage, if the current is brought down, the copper conductor's thickness, that can also be brought down, because the current density for a particular conductor is already set in stone. It is depending upon the material property. So if I bring down the current, the cross section of the conductors can be brought down. That is also decreased. So the amount of copper you are using for making these conductors carry a current, that is also going to be brought down. So overall, the cost of the transmission system can be brought down. That is the reason why we always transmit power at high voltages. So this is always done at high voltage.
Ma'am,
Okay.
can you tell that RLC, what is it?
Resistance, inductance, and capacitance. These are the elements in a network. And we are going to have voltage sources and current sources as the sources in a network. Okay. So we will be talking about these things in detail in our fundamentals of electrical engineering or principles of electrical engineering course. These are passive elements, whereas these are going to be active elements. So we will be talking about this. Apart from this, we might also be looking at dependent sources, where the source is going to be a voltage source or current source whose value may be dependent upon another element's current or voltage. So it can be current dependent current source or voltage dependent voltage source. So you can have current dependent current source, for example, or I can have a voltage dependent current source. So I can have voltage dependent current source, or I can have voltage dependent voltage source and voltage dependent current source. Either way is possible. So I can have, basically, if I am looking at a source, the source is generally mentioned like this. If it is a DC source, it will be plus and minus like this. If it is an alternating voltage source, it will be like this. If it is DC current source, I may be mentioning like this, or it can be, if it is a dependent current source, I am going to have generally, this is going to be the kind of, manifestation or representation. So this is a dependent current source. So whenever I am going to have a diamond kind of, shape, that is a dependent source. And if it is a dependent voltage source, I will show it like this. This is just a representation. For whatever reason, this has been the representation that has been followed. So this is going to be a dependent voltage source. And this is basically an independent DC voltage source. Okay, so this is AC voltage source. And this is going to be a current source. So every time you see a diamond kind of shape, then it is a dependent source. Whereas when you see a circular shape, it is an independent source. So these are different types of sources and passive elements that we will be dealing with subsequently in our various lectures. So let me show you basically what all modules that we are going to have in this, this particular course. So let me probably go over this with magnifying this a little bit. Are you able to see this now? Are you able to see this?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So in the module 1, we will be looking at different types of circuit elements like R, resistance, inductance, capacitance, and different types of voltage and current sources. And we will be looking at how to reduce series and parallel combination of resistances, which you must have already learned. So I am assuming that you will know that to some extent. Then we will be looking at KVL and KCL, Kirchhoff's voltage law, Kirchhoff's current law. And we'll also be looking at the nodal and mesh analysis as to how to use them to ultimately, solve many of the networks. Solving a network means if I am given the source, how will I know what is the kind of voltage and what is the kind of current that is flowing through my network or circuit in every element. So that is what we mean by solving a network. We'll also be looking at what is superposition theorem and what do we mean by linearity condition. So all these things, hopefully we will be able to do it in about 4 hours of lecture, because you guys have at least some familiarity, hopefully, with Ohm's law and resistance network. DC network, you must be having some familiarity. So we will be able to complete this hopefully in 4 hours. Then in the second module, we'll be looking at star and delta transformation. What I mean is, if I'm going to look at star and delta transformation, star is generally when you connect probably 3 resistances or 3 impedances in this form. So this is basically star connection. The same thing can be connected in delta. So delta formation is something like this. So if I connect 3 resistances in the form of star or delta, can I convert star to delta and delta to star? Because very often we use this kind of conversion whenever we have a complex resistance network. And how to convert, for example, if I may call this as terminal A, terminal B, and terminal C, and I'm going to call this as A, again B and C. I may call this resistance as RA, this as RB, and this as RC. Whereas I may call this as RAB because it is connected between terminals A and B, and this is connected between B and C, and this is going to be connected between C and A. Can I convert the star connected formation into delta and vice versa? So how do we do this? This we will be looking at eventually in your second module. And we will be looking at different types of network theorems like Thevenin's, Norton's theorem and maximum power transfer theorem. Each of these theorems we will be taking up some examples and we will try to see how to solve a particular circuit or network using these theorems. And this network can have dependent sources or independent sources. It doesn't matter. Either of them can be employed in these circuits, and how to solve these circuits we'll have to look at. Then in module 3, we'll be looking at RL, RC and RLC circuit transients. What we mean by transient is we just switch on a network, and at that point, how does the current build up or how does the voltage build up slowly in these elements? That we are going to look at. That is generally known as transient response. And we will also be looking at, once we switch on the circuit for quite some time, if we leave it in on condition or off condition, how exactly the responses of the resistance, inductance and capacitances are. Those are known as steady state responses. So we'll be looking at transient and steady state response. And we will also be looking at, until now we had looked at only DC. So we will be looking at, if we apply AC, in that case, how does the circuit behave? So sinusoidal steady state circuit analysis we'll be looking at eventually after looking at the transient circuit responses. So that will take about 4 hours. Okay. In module 4, we will be explaining as to how to use complex numbers while calculating the sinusoidal quantities in an AC network. So this is definitely a new concept that we will be introducing to you in this particular course. So we will be introducing this in the form of complex numbers, and those are generally known as phasors, and we'll be looking at phasors and phasor diagram. And we will be looking at how to calculate power and real and reactive power, and we'll be also looking at power factor. So all these things we'll be talking about in module 4. And after looking at sinusoidal steady state circuit, when there are 3 phases, A, B and C phases that are generated from the generating stations, how do we calculate in 3-phase circuit the power, the 3-phase power, and those things we'll be talking in detail in module 4. So that will take about 7 hours. And finally, in module 5, we'll be talking about resonance, and we will also be talking about transformers, because transformers are one of the major elements for stepping up and stepping down the voltages. And ultimately, we will at least make some foundation for, telling you about generators and motors where electromechanical energy conversion is taking place. Either electrical to mechanical or mechanical to electrical energy conversion is taking place. So this will be only the basics of motors and generators that we will be dealing with. We will not really get into great details of electrical generators and motors, because that will be taken up in the subsequent course which will come up in electrical machines for electrical engineering students. Particularly, maybe electronic engineering students may not be doing much in machines, but at least you should know the basics of how the electrical to mechanical and mechanical to electrical energy conversion takes place. Okay. So if you look at the total amount of lecture hours I have given here, this is 4 plus 4, 8, 8 plus 4, 12, 12 plus 7, which is 19, 19 plus 8, 27, and 1 hour is spent in introduction. So totally 28 hours of lecture we will be having in this particular course. So there will be about 14 weeks of classes. Okay, each week having 2 hours of classes. Okay, fine. Now, as far as the reference books are concerned, these are the 3 major reference books that I have given here. You can see this. Electrical and Electronic Technology by Edward Hughes. So this is the book that I am talking about. And I have a soft copy of this book. I'm sure you will be able to get a soft copy too. But this covers almost everything under electrical and electronic engineering. So this may be a useful book if you are planning to prepare for GATE exam or any other exam at some point in time. This is one of the old books that is available, but this is the 10th edition, which has been, updated quite a bit. And this is the other one, which is Basic Electrical and Electronics Engineering by Nagrath and Kothari, which is actually from McGraw-Hill Education, India. So McGraw-Hill, India. So this is also available probably in the form of soft copy as well. Okay. And the third one is the third book is by Smith and Darf, which is from John Wiley. This is called Circuits, Devices and Systems. Yeah.